You know, to really get your head around something like Kubernetes, you can't just look at what it is today. You got to go back. You have to understand the absolute mess, the history of pain and failure that made it so necessary. So that's what we're going to do. We're going to tell that story.
All right, let's kick things off with a big question. Think about a super successful app, right? A startup that's just taking off. What's the number one thing that could kill it? Is it, I don't know, their competitors, a terrible business plan, maybe a massive security breach?
Nope, it's none of those. The biggest threat, believe it or not, is its own success. And this is a classic problem. We call it the crisis of scale. It's this cruel irony where the very thing you've been working for, all that growth, is exactly what ends up bringing your entire system to its knees. And that is the core problem we're going to unpack today.
Okay, Section 1, from iron to virtualization, also known as the era of pets. Our story starts way back in what you could call the Iron Age of computing. Let's imagine a little startup. We'll call them Streamco. They're brand new, and their whole operation, their entire app, runs on one single physical server. You know, a big metal box in a rack. Sounds simple, right? Well, that simplicity, it's hiding a ticking time bomb.
And the first major problem they slam into is something developers lovingly call dependency hell. Just picture this. Streamco's server is running their main application, and it depends on an old, super stable software library. But now, they want to install a new analytics tool, and that tool needs the latest version of that exact same library. What happens? Well, the moment they install the new tool, it overwrites the old library, and poof, the main app crashes. This led to a really rigid and really expensive rule. One app, one server. Period.
And this chart just shows you how crazy the consequences were. Because of that one app, one server rule, most data centers were just shockingly inefficient. I mean, we are talking about an average server using maybe 15% of its total power. To put that in perspective, for every $1 million you spent on hardware, $850,000 of that was just paying for expensive, power-hungry paperweights to sit there doing absolutely nothing.
So this whole era was ruled by what we now call the pet philosophy. And it's exactly what it sounds like. Every server was a unique little pet. It had a name, right? Like Zeus or Apollo or whatever. And when it got sick, when it crashed, a system administrator would have to log in and spend hours, sometimes days, nursing it back to health. Why? Because rebuilding one from scratch was a complete nightmare. Each server was this fragile, hand-built, totally irreplaceable thing.
Now, to have any hope of scaling, this entire mindset had to flip. We had to stop treating servers like pets and start treating them like cattle. Think about it. In the cattle model, the servers are all identical, they're anonymous, they're disposable. If one gets sick, you don't waste time trying to fix it. You just replace it automatically with a brand new, healthy, identical one. And this shift in thinking, it is absolutely crucial for everything that's about to happen. So the first big breakthrough that made this possible was the virtual machine, or VM. You had this clever piece of software called a hypervisor that could take one big, powerful physical server and just slice it up into a bunch of smaller, completely isolated virtual computers. So now you could finally run your main app in one VM and your new analytics tool in another, on the exact same physical machine, with zero conflicts. Problem solved. Kind of. And the economic impact of this was just huge. It enabled this idea called bin packing, which is a fancy way of saying you could cram a lot more applications onto a single server. Those utilization rates, they shot up from that pathetic 15% to more like 70%, even higher. But, and this is a big but, this solution wasn't perfect, not by a long shot. It just created a whole new set of problems. Which brings us to Section 2, the container revolution. Lighter, faster, better. See, VMs solved the dependency problem, but they were heavy. They were big. Each and every VM had to run its own full-blown operating system. This wasted a ton of resources. People called it the hypervisor tax. And crucially, they took minutes to start up. In a world that's demanding instant scale, minutes might as well be an eternity. And this leads us to probably the most infamous, most frustrating phrase in all of software development. You've probably heard it. A developer says, "But it works on my machine," right? They build something on their laptop, it's perfect, then they ship it to the real servers and it just completely falls apart. Why? Because their laptop and the server are two totally different environments. Well, containers, which were made super popular by Docker, showed up with one incredibly powerful promise: to destroy that phrase forever. The whole idea of a container is that it packages up not just your app's code, but everything it needs to run.
all the libraries, the configuration files, the whole shebang, into one single, neat little box that works the same everywhere. And this table just lays out the difference, and it is dramatic. A VM has to pretend to be a whole physical computer, so it needs a full guest OS. That makes it huge. We're talking gigabytes, and super slow to start. A container, on the other hand, does something much smarter. It virtualizes the operating system itself. It shares the main OS of the machine it's on, which makes it insanely lightweight, megabytes instead of gigabytes. And it boots up in milliseconds, not minutes.
But here's the twist. Of course there's a twist. This amazing efficiency created a brand new, even bigger nightmare. The problem of managing, say, 10 big, slow VMs was suddenly replaced by the problem of trying to manage 1,000 tiny, fast-moving containers. We call this container sprawl, and it basically set the stage for complete and utter chaos.
All right, Section 3. Enter the orchestrator. Time to tame the chaos. This brings us right back to our startup, Streamco. They've gone all in on containers. Their app is a monster hit, and it's Black Friday, the biggest, most important sales day of the year. And thanks to all that container sprawl, their entire system is about to just implode.
So this disaster unfolds in like 3 acts. First, the traffic spike hits. It's massive. But their process for adding new servers is all manual and it's way too slow. The site crashes in 2 minutes, but it takes 5 minutes to get a new server online. Game over. Second, in a total panic, an engineer tries to manually place a new container on a server they think has some space. It doesn't. The server runs out of memory and crashes, taking 20 other perfectly healthy containers down with it. And finally, even if they do manage to get some new containers running, their main router, the load balancer, has no idea where they are. It doesn't know their new IP addresses. It's a complete top-to-bottom system failure.
And a failure like that leads you to a really profound realization. Humans just can't keep up. You can't manually juggle hundreds or thousands of these little moving pieces. At a certain point, the system gets so complex that it demands a machine to manage the other machines.
And that machine, as you've probably guessed, is Kubernetes. Now, the core idea behind Kubernetes is fascinating. You don't tell it what to do, you tell it what you want. You give it a desired state. You basically write a file that says, hey, I want 5 copies of my web server running at all times. And then Kubernetes just enters this relentless loop. It observes the system, it compares what it sees to what you want, and then it takes action to make reality match your goal, over and over and over. It never stops.
Okay, so let's replay that Black Friday disaster, but now Streamco has Kubernetes. First problem, it's 3 a.m. and a server just dies. Totally crashes, and it takes a bunch of our app containers down with it.
With Kubernetes, nobody panics. The system is constantly running these little health checks on every single container, called liveness probes. The second those containers on the dead server stop responding, Kubernetes just goes, okay, they're dead. That reconciliation loop kicks in, it sees the current state, maybe only 2 web servers are running, and it knows the desired state is 5. So what does it do? It automatically starts 3 brand new, healthy replacements on the other servers that are still alive. The system literally heals itself, probably before an engineer's alarm even has a chance to go off.
And it just as elegantly solves all the other Black Friday problems. That whole server Tetris game of trying to find a machine with enough space, forget it. The Kubernetes scheduler finds the best spot automatically. That nightmare of tracking IP addresses, gone. Kubernetes Service Discovery gives a whole group of containers one stable, unchanging name. You never have to think about IPs again. And what about taking the site down for updates? Nope. Kubernetes does rolling updates, where it replaces the old containers with new ones, one by one, so your users never even notice. Zero downtime. And that brings us to our final section, the new standard. We've moved from servers to self-healing systems. When you look at this whole journey, from physical servers to VMs to containers and finally to orchestration, it's a massive shift in thinking. We've gone from being digital gardeners, manually tending to each server, to being more like architects who just define the blueprint for a system that can build and heal itself.
And this table really just drives the point home. Look at the difference. Every single one of those manual, slow, risky jobs on the left becomes proactive, automated, and fast on the right. Scaling, recovery, updates, efficiency. It's a night and day difference. It isn't just a small improvement. It is a totally different way of thinking about how we run software on a massive scale.
You know, when you really boil it down, maybe the most profound thing Kubernetes did was make the individual server totally irrelevant. You stop caring about server 5 or server 10. You only care about the health of the entire cluster, the whole system. And that leaves us with a really interesting question to chew on, right?
This wave of technology made the server itself kind of fade into the background. So what's the next thing that's going to become irrelevant?